If we're talking XSS prevention, the first thing is separating the flavors. Stored XSS is the nasty one that gets saved in the database and hits everyone who views it. Reflected XSS comes straight back from the request, usually through a link or form. DOM-based XSS stays entirely in the browser when JavaScript takes unsafe data and shoves it into the page.
Right, the surprise. Your own app betrayed you category.
Exactly. Stored is often the most damaging because it scales silently. Reflected is more obvious but still ugly. DOM-based is the one people miss because the server logs look clean, and everyone blames the backend for a week.
Been there. The front-end code was the real accomplice.
Prevention is mostly boring discipline. Encode on output. Sanitize only when you truly need rich text. And never trust user input in HTML, attributes, or script contexts.
And avoid inert null like it owes you money.
Pretty much. Use text content, safe templating, and a strong content security policy.
CSP is great until someone says, just add one inline script.
Input validation and output encoding get mixed up all the time, and they're not the same job. Validation is about checking whether the input makes sense for your app. Encoding is about making sure the data is safe in the place you're putting it.
So validation is this allowed? And encoding is don't let it bite me later.
Exactly. If someone enters a phone number field with angle brackets, validation should reject it if the field expects digits only. But even if validation passes, you still encode before rendering it into HTML or an attribute.
Because clean input can still be dangerous in the wrong context.
Right. Dual. Validation helps reduce bad data early, which is great for quality and abuse prevention, but it doesn't replace output encoding. I've seen teams validate on the way in and then dump raw strings into a template like it's a victory lap.
That's the kind of confidence that keeps security people employed.
And tired. Also, context matters. HTML encoding is not the same as JavaScript encoding, which is not the same as URL encoding.
Different locks, different keys. Simple enough.
Simple, yes. Easy, not so much. That's why context-aware escaping matters. The same string can be safe in one place and dangerous in another.
Like how a harmless name tag becomes a weapon if you drop it into a script block.
Exactly. In HTML text, escape angle brackets and ampersands. In attributes, you also need to worry about quotes, and whether the attribute is even quoted properly. In JavaScript, you're dealing with string delimiters, backslashes, and sometimes Unicode edge cases. URLs need %encoding, but that doesn't make them safe to inject into HTML by itself.
So one escape function to rule them all is basically a trap.
A very common trap. I've seen code that HTML encodes a value, then puts it into an on-click handler and calls it secure. That's how bugs get a long shelf life.
Great for archaeology, terrible for production.
The safest path is to avoid mixing data and code at all. Use templating systems that auto-escape based on context, and keep untrusted data out of script blocks unless there's no alternative.
And if there is no alternative, assume it's going to hurt.
Which is where content security policy earns its keep. It's not a fix for bad code, but it's a solid backstop when something slips through.
A seatbelt, not airbags.
Good analogy. A strict CSP can block inline scripts, limit script sources, and reduce the blast radius of XSS TAW. But if you design it badly, you'll end up weakening it fast because everyone wants their widget, analytics snippet, and temporary exception.
Temporary meaning forever, obviously.
Usually. The trade-off is security versus operational friction. Nonces and hashes are cleaner than allowing broad domains, but they take discipline. And if your app relies on a bunch of inline handlers, you'll spend time paying down that debt before CSP becomes effective.
So the policy is only as good as the app's habits.
Exactly. You also have to think about reporting. A CSP violation report is useful only if someone actually reads it and fixes the root cause instead of just silencing it.
That's the fun part nobody budgets for.
Security rarely does. User-generated content is where things get messy fast, especially if people want rich text. Plain text is easy. Escape it and move on. Rich text means you're letting users bring in some markup, and now you need a sanitizer that strips dangerous tags, attributes, and protocols without breaking everything useful.
So the challenge is letting people say what they mean without letting them smuggle in a script tag.
Exactly. And if you're storing comments, profiles, or forum posts, sanitize on the way in, then still encode on the way out. Don't assume one layer is enough.
I've seen sanitized content come back as a little science experiment after a framework upgrade.
That happens when people rely on permissive allow lists that drift over time. You need a well-tested sanitizer, a narrow set of allowed elements, and regular review. Links are another trap. Even if you allow anchor tags, you have to block JavaScript, URLs, and weird data URI cases.
Users always find the edge case you didn't think was charming enough to test.
Right. So treat rich text as a controlled exception, not a default feature. Most modern frameworks help a lot by auto-escaping templates by default, which is good, but people get complacent and then poke holes in it.
The framework will save me is always a risky personality trait.
It is. React, Angular, Vue, Django, Rails, they all have defenses, but the bypasses usually come from developer choices, raw AutoML rendering, dangerous DOM APIs, custom directives, or disabling protections for convenience.
So the framework is locked, and someone just leaves the side door open.
Exactly. Another common bypass is misunderstanding context. A templating engine may escape HTML, but if you later inject that same value into a JavaScript string or an attribute via a manual DOM update, you've stepped outside the guardrails.
And then the bug report says, framework X vulnerable, when it was actually human bypass framework X.
Pretty much. You also have to watch for framework-specific syncs and helpers that sound safe, but aren't if used incorrectly. A lot of teams think, we use a modern framework, so XSS is handled.
That confidence lasts right up until the first security review.
Or the first incident.